In this session, we are going to take a good look into united machine and deep learning. Let's start. Machine learning, abbreviated as ML, and deep learning, abbreviated as DL, are closely related technologies within the field of artificial intelligence. Now attention. While all deep learning is machine learning, not all machine learning is deep learning. When to use which? Most real-world AI applications today actually combine both approaches. Developers often use traditional machine learning for core business logic and switch to deep learning when handling unstructured perception tasks. Now, for a visual walkthrough breaking down exactly how artificial neural networks are structured and the number of layers that distinguish a deep learning model from a traditional machine learning, remember, algorithm. Machine learning. Traditional machine learning requires human intervention to identify specific features a model should look at. How it works? Engineers extract and define key features from data and feed it into algorithm, for example, like decision trees or linear regression. Data needed. Performs well on smaller structured datasets. ML is best used for tabular data, predictive analytics, predicting housing prices, and filtering spam. Pros and cons. Models are highly transparent and easy to interpret, but require heavy human labor for data preparation. Deep learning mimics the structure and function of the human brain neural network to process information. It gets the word deep from having many layers of neurons that pass data to one another. How it works? These models bypass the need for human-defined features. Instead, they ingest raw, unstructured data and automatically extract the important patterns layer by layer. Data needed requires massive data sets and high computational power to train effectively. Deep learning is best used for complex, unstructured data like images, speech, and text. Pros and cons. Unlocks incredibly powerful capabilities, but is often seen as black box because it is difficult to interpret exactly how the model made its decision. Let's take a look at machine and deep learning tools. Yes, there are specific tools for each artificial intelligence field. Let's start. Machine learning tools are frameworks, libraries, and platforms used to build, train, and deploy predictive and intelligent models. They streamline everything from data preprocessing to complex neural network training, scaling from local laptops to enterprise cloud operations. Deep learning tools are software frameworks, libraries, platforms used to design, train, and deploy artificial neural networks. They provide the foundational architecture for building everything from computer vision models to large language models. The most popular tools are Python, TensorFlow, and Keras. Machine and deep learning tools are software libraries and cloud platforms used to build, train, deploy, and manage AI models. Standard libraries like scikit-learn handle traditional data modeling, while advanced frameworks like TensorFlow, PyTorch, and JAX power deep neural networks. And finally, let's take a look at machine and deep learning tools classified or classification. First of all, we need to understand classical machine learning frameworks. These tools handle the basics like data preprocessing, regression classification, and clustering. Scikit-learn. It's Python library for classical machine learning tasks, for example, like classification, regression, clustering, built on NumPy and SciPy, making it highly accessible for student and analyst. Popular one, Jupyter Notebook. This is open source web application for interactive coding, data visualization, and documentation, heavily used for prototyping Python and R scripts. Besides C++, C Sharp, Python, Java languages, there is additional R language. Weka, Java-based suite of machine learning algorithms that features a graphical user interface, making it great for beginners who do not want to code immediately. Accord.NET, judging at .NET extension, a .NET framework by Microsoft for scientific computing that provides algorithms for numerical linear algebra statistics and artificial neural networks. So far, we covered classical machine learning frameworks. Next classification, deep learning frameworks. These open source libraries are built for constructing complex multi-layer neural networks to process unstructured data like images, audio, text. There are a few popular ones. TensorFlow, developed by Google, this highly scalable library is excellent for large-scale deep learning and natural language processing workflows and robust production deployment capabilities. PyTorch, developed by Meta, this framework is deeply favored by researchers and developers for its flexibility and Pythonic nature based on Python language, dynamic computational graphs, making it ideal for rapid prototyping and artificial intelligence research. Keras, high-level, user-friendly neural network API written in Python that can run on top of TensorFlow, all Python related, making it easier to build and experiment with deep learning models. JAX, high performance computer library by Google, uses so-called XLA or accelerated linear algebra for massive speed improvements on TPUs. So far, we covered classical machine learning networks, deep learning frameworks. Next one. Enterprise, ready-to-go cloud platforms and MLOps. MLOps is machine learning operations like DevOps, development operations. As models move from research to production, cloud platforms and MLOps tools are used to manage, track, deploy, and scale them. There are a number of ready-to-go cloud-provided platforms. Amazon SageMaker, managed cloud service that allows developers and data scientists to build, train, and deploy machine learning models quickly. Microsoft Azure Machine Learning, end-to-end cloud platform used to build, train, and deploy ML models with comprehensive lifecycle management, provided by Microsoft. Google Cloud Vertex AI integrates Google's machine learning tools and AutoML capabilities into a unified environment for training and deploying AI models at scale. Please notice at this point there are three major cloud providers in the world: Amazon Web Service, Microsoft Azure, and Google Cloud Platform. Three of them have own solutions for artificial intelligence. MLflow, open source platform designed to manage the machine learning lifecycle, including experimentation, reproducibility, and deployment. And specific one, Google Colab, hosted Jupyter Network Service, which requires no setup and provides free access to computing resources, for example, including GPUs, TPUs. So, next classification is MLOps deployment and production, machine learning operation deployment or production. There are three of them so far, there will be more later. Hugging Face, premier hub for open source AI models, datasets, and libraries used for deploying state-of-the-art text and vision models. MLflow, open source platform to manage machine learning lifecycle, including experimentation, reproducibility, and finally deployment. This one is interesting, is Weights and Biases is a platform designed to help track deep learning experiments, visualize metrics, and manage model versions. Next classification. There are two final ones: easy to use high-level APIs and code-free and automated machine learning. So, easy to use high-level APIs. Keras, highly accessible, user-friendly deep learning API, runs primarily on top of TensorFlow, allowing for rapid prototyping, Python-based. Another Python-based PyTorch Lighting, lightweight wrapper for PyTorch that automates hardware training and reduces engineering bugs. And code-free and automated ML. There are two interesting ones. Very popular NIME, an open source platform that allows users to build data pipelines and machine learning workflows visually without needing to write a code. Very popular one. And RapidMiner, another visual data science platform designed to speed up the model building process for both non-programmers and experts. So, there is a number, big number, and there will be more later as artificial intelligence progresses. Machine and deep learning tools classified by classical machine learning frameworks, deep learning frameworks, enterprise ready-to-go cloud platforms, and MLOps. MLOps deployment specific for production, easy to use high-level APIs, and code-free and automated ML. See you in the next lecture.